In this video, we're going to look at the periodic table and drawing atoms. So the periodic table is arranged according to increasing atomic number. The vertical groups are called groups, vertical columns. The horizontal rows are called periods. The periodic table can be separated into two distinct parts, metals and non-metals. Metals are found on the left of the periodic table. Non-metals are found on the right of the periodic table, and they're separated by the staircase, which you can see really clearly on a periodic table. Metals conduct electricity. Non-metals do not. When metals react with oxygen, they form oxides that have a basic nature or an alkaline nature. When non-metals react with oxygen, they form oxides that are acidic. So drawing atoms. We can draw diagrams to show where the electrons are found in the atom. The rule we need to remember. The first shell can hold 2 electrons, and the rest of the shells can hold 8 electrons. So we're going to do 2 examples here. We're going to look at oxygen and chlorine. You can pause now to find out how many electrons oxygen and chlorine have from your periodic table. So after looking at your periodic table, you should have discovered that oxygen has 8 electrons and chlorine has 17 electrons. We'd fill these in from the inside shell first. So, based on our rule that the first shell can only hold 2 electrons, oxygen must have 2 electrons in there. This leaves 6 electrons for the next shell. It's really important that you draw these in a way that an examiner can see really clearly. So to do that, we draw the electrons in pairs. 1, 2, 3, 4, 5, 6. We can write what's called an electronic configuration to tell a person where the electrons are found. And for oxygen, that looks like this. 2, 6, meaning there are 2 electrons in the first shell and 6 in the outer shell. For chlorine, it has 17 electrons, so it's going to have 2 electrons in the first shell. It's going to have 8 electrons in the second shell. Remember, that's the maximum the second shell can hold. We draw them in pairs so that it's really clear for an examiner to see. There are now 7 electrons remaining in chlorine's next shell. Again, we draw them in pairs. And there's 1 more electron by itself there. The electronic configuration for chlorine is 2, 8, 7. Meaning there are 2 electrons in the first shell, 8 in the second, and 7 in the outer shell. Some really useful pieces of information here. The number of shells is the period number that the element is in on the periodic table. The number of outer electrons is the group number. So for example, for chlorine, it has 3 shells, so it's in period 3, and it has 7 outer electrons, so it's in group 7. As a general rule, the number of electrons dictates the type of reactions that a chemical will be involved in or an element will be involved in. So elements in the same group have very similar chemical reactions, and that's because they have the same number of electrons in their outer shells.